There is a gas in this question that is being put into two different conditions. First is at the temperature of 300 Kelvin and pressure of 16 kilopascal. Then after that, conditions are changed. It is compressed until the volume of gas is half. Temperature changed to 375 Kelvin. Pressure is increased to 40 kilopascal. This time we are going to look at answer B first. Answer B says that it is possible to calculate the number of moles of gas present using this data alone. So we want to see whether statement B is correct or not. Now let's look at the first conditions. Temperature 300 Kelvin. Pressure is 16 kilopascal. You might be thinking that we can use PV equals to nRT, the ideal gas equation, to calculate N. So let's try this. PV equals to nRT. P is 16,000 Pascal. Volume here is not given. We are only told that it will be compressed to half of its original volume in the second experiment. N is unknown here. R is the gas constant, 8.31. T is 300. It is given in the question. Now, can you see that in this equation, we have two unknowns? So that means it is not possible to calculate the number of moles of gas present in the experiment using this data. So B is incorrect. Now, if you look at answers A, C, and D, we can prove all of them correct or incorrect by using the same method, which is by proving whether the gas is behaving ideally or not. If the gas is behaving ideally, if C is correct, then A will be incorrect because in ideal gases, intermolecular forces between the gas molecules are not significant. If we can prove that the gas is behaving ideally, then A is incorrect. Also, if we can prove that the gas is behaving ideally, D will be incorrect too, because ideal gas behavior is not affected by the change in the pressure. No matter how we increase the pressure, the intermolecular forces between the gas molecules are not significant. So if C is correct, A and D will be incorrect. How to prove that the gas is an ideal gas? We need to use PV equals to nRT again. The number of moles of gas is not changed throughout the experiments. Although the pressure and the temperature has changed, but the number of mole is the same. If I rearrange this equation to PV over RT, I'll get N. And N is not changed, so this will be a constant. I can prove that P1 V1 over RT1 is the same as P2 V2 over RT2, which is a constant. The gas is behaving ideally. So let's try this. P1 will be the first condition, 16 kilopascal, 16,000. V1 is not given, so just put it as V. R is 8.31. T1 is 300. First set of conditions will give me a value of 6.42V. Now let's try for the second set of conditions. This time P2 will be 40 kilopascal. Volume is half, so let's put it as 1 over 2V divided by R again, 8.31. This time the temperature is 375 Kelvin. I get the same value, 6.42V. So this gas is an ideal gas. Intermolecular forces between the gas molecules are not significant. A is incorrect. The pressures used are too high for ideal gas behavior, which is also incorrect for ideal gas. And the answer to this question is C.